Hi, this is Mr. McKee with SEC150. I want to go ahead and go over one of the problems for the, let me get it up here, the network ID assignment. Alright, so basically it wants you to, it gives you the networking prefix, which is the CIDR notation. It gives you an example of the first one. It's a \24, which is a 255.255.255.0 subnet mask. You'll have 8 subnet bits and 254 hosts. And the reason you have 254 hosts, not 256, is you have your first address, which is 0, is going to be your network ID. Alright, right there. And then the very last address is going to be 255, and that's your broadcast address. Neither one of those you're going to assign to hosts. Alright. Now what I did, and I'm going to attach this, well actually I put it up on Moodle. I went ahead and made a subnet calculator, and don't let the name of it mislead you. This isn't really a calculator at all. It just kind of like points out the main points of calculating subnets, because I don't want you guys to get a subnet calculator and not be able to understand actually what's happening. Subnet calculators are great. They're good for double checking, but you guys need to know how to do subnetting and variable length subnet masks eventually. Alright, so I made the spreadsheet. Basically what you have the binary. These are all your bits. 32-bit subnet, 32-bit IP address for IP version 4, 8, 16, 24, and 32. 32 bits total. Alright, so in decimal, the very rightmost bit is going to give you either a 0 or a 1, and then it keeps going up, it keeps doubling. Alright, so pretty much if you look at all these, if you had a 255, 255, 255, 0, kind of like this first example, you're going to have, add all these up, and you get 255 because it's not showing 0, but all zeros for all these bits is going to give you 0. So total 256, which is the next row, 256 possible addresses. Alright, you can't have all zeros and you can't have all ones, because that'll give you either 0 or 255. Alright, and I've just put on here Class A subnets, correction, IP addresses 1 through 126, and then you have Class B is 128 through 181. 127 is not here because that's a your local address, and then 192 through 223 is your Class C address. Now that's class full addressing. All right, some of these questions are not classful. All right, and what we're going to do is, here's a good one right here, 10.1.96.0, and a CIDR notation of 19, and basically that 19 is saying, okay, cover up 19 of the leftmost bits, cover up 19 of them for the network mask, and then the rest is left for the hosts. Alright, so you're going to have a whole bunch of addresses looking at that address. Alright, so this, I'm just show you guys how I do it. Alright, your IP and CIDR notation right there, 10.1.96.0, and it should say on here, but that's definitely the network address. That's not a IP address for a computer. Alright, and then \19. So basically, let me cancel this out. Alright, so first octet's 8, second octet's 16, 17, 18, 19. CIDR notation of 19. Alright. Highlight that just to show you guys the network. Alright, there's your network address. Alright, so look in here, all these bits can be used for hosts. Alright. So basically, looking here, and I have this set up just like Cisco's way to configure subnets. I just go by that. I'm used to doing it. Makes sense to me. Remember magic number 256, which means possible positions in here. 256 positions, 256, 256, 256. All right. So I'm going to put an IP in here. 10, 1, 96, 2. You guys don't have to worry about that. All right. Subnet mask 19. So all these are taken up. So that's going to be 255. All of these are taken up. 255. All right. And then if you start chopping these up, if you take one bit off there, you'll have a 255, 255, 128. You chop another bit off, you'll have 192. Chop another bit off, 224. Alright, so that's where we are. And if you keep going, 240, 248, 252, 254, and 255. Alright, and what that means is if these are my host bits, these are my, correction. Say if these were all my network bits, these are all my host bits. I can chop off these bits to make separate subnets if I want to chop these up more. All right, but just remember half of 256 is 128. Half of 128 is 64, so 64 plus 128 is 192. Half of 64 is 32, so 192 plus 32, 224, and then so on. That's half of 32, 16, half of 16, 8, half of 8, 4. See how these are going up by 4, going up by 2, going up by 1, and then you won't have 256. All right, so a 19, 16, 17, 18, 19 is going to be 224, 0. So if we look right here, if it's 255, you bring down the same number. So it's definitely going to be a 10.1 dot something. All right. We know the network address, which is going to be 96.0. All right. First subnet's going to be 10.1.96, just this next one in line. All right. And what we're going to need to find out, though, this is the fun part. All right. So magic number 256. If we take 256 and subtract 224 from that, 256 minus 224, that equals 32. I just know that off the top of my head, and if I put it equals, it'll make more sense. All right, so 32. If I do 32 plus 96, that's 128. All right. So this is going to be 128. What you got to do is make sure you subtract 1 from it. All right. So 127, and it's going to be 255. All right. And what you can do is, let's see, 32. Let's do the last host address is going to be 1 less than the broadcast. 127. 1, 10, 10, 1. All right. That may not make a lot of sense to you. If it's 255, you bring down the same IP address for both of those. 224, you use the magic number of 256 possible positions in here. All right. Subtract 224 from that, which gives you 32. You just got to make sure you subtract 1 since you got 255 right here, which plus 0 is 256. So if we take 32 minus 1, is 31. So that's going to be 30. We have 32. All right, correction. 31 times 256. All right. Times 256 plus 255 equals 91. All right, so 8191 and then plus a 0 in the end. That gives us 8192. All right. So 892 possible addresses minus 2 for our subnet and our network, and broadcast equals 8190 host addresses. Alright, so there we go. 8190 possible addresses. Let's see what it asks us here. So what we're going to do is, and I didn't do all these for you, I want you guys to be able to figure them out yourselves and practice. So you got 255.255.224.0 host bits. You're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 host bits. Alright, number of hosts. And you can kind of check your answer right here also, because you can do 13. Actually, not that. 13 host bits. 8190 number of hosts, and then you come down here and look for your same network ID, which is 10.1.960. And this really doesn't tell you how many hosts, but you guys can just put in 8190 down there also. Host bits needed 13. Alright, kind of like that. Network ID. This is just showing you how to do it kind of backwards. 6.0/19. Alright. So you have 890 possible host addresses. Alright. And it shows you right there. And if you do 2 to the 8, 9, 10, 11, 12, 13. 2 to the 13th power. You can double check it. Alright, let's go to scientific. You guys are, computers probably set on standard. If you do scientific, you have the exponents right here. So 2 is going to be x, and then hit that. 13th power equals 8192. So we just verified that the possible addresses from here to here is 8191 in your sum, plus you'll have a 0. Alright? And that's your network address. It starts with 0. Alright? So just remember 127 minus 96 gives you 31. 31 times 256 plus 256 is going to give you 8192. And let's just make sure. So 31 times 256 equals plus 256 equals 8192. Alright, and Hopefully that makes a little bit more sense, but if you got to have a 255 here and then a 127, and you just have to remember you have to subtract 1. Make sure your magic number is 256 minus whatever your subnet mask is right there. All right, and you're going to add that to the 96 down here in your